Welcome back to yet another chapter of PropelAPilot. In this chapter, we are going to discuss about performance and weight and balance. Now, why do we need to know about performance? By understanding performance and knowing how to calculate their performance values for a given day, a pilot can determine if a runway is sufficient for the takeoff or landing. Will the airplane be able to safely climb over and above the obstacles? What will be your cruising speeds? How much fuel are you going to burn at a particular altitude for a given RPM settings? All of these questions can be answered once performance is understood properly. To describe the effectiveness of an aircraft in the job that it is supposed to do, the job that it is designed to do, we use the term performance. Different designs emphasize speed, maneuverability, load carrying capability, or the ability to handle short, rough fields. Aircraft designers usually try to accentuate specific performance characteristics at the expense of others. For example, a competitive aerobatic airplane is extremely maneuverable, but the load carrying capacity or the payload capacity of the airplane is nothing other than the pilot. On the other hand, an aircraft used and designed for payload cross-country cargo carrying capacity has a lot of stability, has huge payload capacity, and is designed for economy of the operation at the expense of maneuverability. The performance or operational information section of the aircraft flight manual or the POH describes the given performance of the aircraft. You will find the different charts to calculate the performance values. The use of this performance data is mandatory for safe and effective operations. Performance charts. In developing performance charts, airplane manufacturers first make certain assumptions about the pilot and the conditions of the airplane, the ability of the pilot and the conditions of the airplane. What are they? The pilot is expected to follow the normal checklist procedures and be able to perform each of the required tasks correctly and at the appropriate time as given in the procedures or in the checklist. Manufacturers also assume that the airplane is in a good condition, airworthy of course, with a properly tuned engine and all of the other systems working normally. Once this is kept in mind, they start conducting flight tests. Now they are not going to perform flight tests for each and every condition that is given in the performance charts in your POH. What they do is they analyze the flight test data and then mathematically derive the remaining information for the remaining values in the performance charts. This mathematically derived information is then published as charts, which can be either tables or graphs in your POH. To be a well-informed pilot, you need to know how to find and interpret the published performance information as well as how to operate the aircraft within the performance limitations imposed by the aircraft design and atmospheric conditions. You must possess a sound knowledge of the performance charts and the operating limitations. Understand this: every airplane or aircraft has its own POH or airplane flight manual. The performance of each airplane differs from one another. Since performance data can vary between similar models, even from the same model of a year to another year, you should only refer to the POH for that particular airplane that you are flying. Performance charts generally present their information in either a table or a graphical format. The table format usually contains several notes which require you to make adjustments for various conditions which are not really accounted for in the body of the table. Graph representations, on the other hand, account more variables, reducing the required adjustments later. To get as close possible to the performance, you must follow all the charts, performance limitations and procedures as well as the notes that are given next to it. Before we go on further, I need you to understand this, that the performance information in the airplane flight manual and the POH is useless if you do not understand how to use the notes or all of these adjustments which are given next to it. We are going to discuss the different factors that affect performance throughout this chapter, And these are exactly the things that you are accounting or adjusting for when you refer to these notes. Of course, of course, you might not be able to get the information for each and every combination of temperature and pressure. You will have to perform interpolation for that. Interpolation is the process of finding an unknown value by using two known values. More often than not, pilots will round off the figures of performance that they calculate from these tables to a more conservative figure. This conservative figure is not wrong, rather, it actually tries to accommodate for slightly adverse performance characteristics of an airplane. Maybe the weather is not exactly what is reported, or the temperature increases. So, this gives a reasonable margin of safety and a good estimate of the real performance. The table format. This is a pretty straightforward format of the charts to use. Just find the row and the column that match closely to the given conditions of weather, and then find the box or the value where both of these row and column intersect. The graphical format, on the other hand, comes in many configurations and arrangements, but all of them are designed to make the process of compensating for several variables easier, fast, and accurate. These variables were shown as notes in the table format, if you remember, but the graphs are designed in such a way that they incorporate these variables during the process of performance calculation without actually making adjustments later. But because of the extra information that is given in the graph, we now have to be extra careful, because you might get a temptation of estimating where two lines intersect on the graph or something like that, that can create an error. A small error during the process of calculating using the graph can create a performance value which is seriously off the actual flight characteristic.